Hey everyone, hope you're doing well. Welcome to a new video. What if I told you that cloud storage infrastructure often reveals itself before you even log in inside the application? During VAPT and red team assessments, cloud buckets can sometimes become discoverable through JavaScript files, response headers, GitHub repositories, archives, mobile applications, and even simple naming conventions. In this video, we'll break down practical cloud bucket enumeration techniques used during authorized security testing. Modern applications heavily rely on cloud object storage platforms like AWS S3, Azure Blob Storage, and Google Cloud Storage. These environments host backups, media assets, logs, static files, mobile resources, and application artifacts. During security assessments, understanding exposed cloud assets become critical because cloud infrastructure frequently expands the external attack surface. Now let's get started with practical demonstrations, and we'll start with everybody's favorite goldmine, JavaScript files. JavaScript analysis remains one of the highest value enumeration techniques. Front-end applications frequently expose storage endpoints, CDN references, upload paths, bucket names, API integrations, and many more. Security teams often analyze JavaScript bundles to identify infrastructure references that could reveal cloud attack surface visibility. To showcase practical demonstration of bucket enumeration from HTML or JavaScript file, we are taking an example of a Secret application and its response as an example. So in this case, if you see, this is a simple request to the main domain. And if you can see here, we are fetching an HTML file which contains S3 bucket reference in the response itself. So similarly, the similar logic can be applied for JavaScript files as well. So whenever a JavaScript file, an HTML file, or any other files are getting fetched from the server, S3 bucket references can also be displayed or disclosed in the response. The second technique on the list is response headers. Header analysis is an important technique for identifying cloud resources and expanding attack surface visibility during security assessments. Headers often provide valuable infrastructure intelligence during VAPT and red team engagements. Application response headers such as CSP, access control allow origin, or other metadata sometimes can reveal underlying cloud storage dependencies, third-party integrations, or even infrastructure components that are not directly visible within the front-end code. To showcase a practical demonstration of bucket enumeration from response header, I have taken one domain here, pixel.tapper.com. If you can see in the response, we have a unique header here, P3P. The unique header here is trying to fetch a policy from the reference of S3 bucket here. So in this case, S3 bucket is being referred and mentioned in the response header itself. Similarly, we can obtain bucket in many cases from headers like CSP also. The third technique on the list is GitHub enumeration. GitHub repositories frequently reveal cloud intelligence. Configuration files, historical commits, and documentation often contain cloud storage references. Even deleted infrastructure occasionally survives inside commit history. As you can see, we have opened github.com and have visited official GitHub repository of Tesla Motors. We will now try to search for S3 buckets by using the search option and entering s3.amazonaws.com. As you can see, we have a lot of matches here. We can see a lot of S3 buckets that might be belonging to Tesla. So we see this is the first bucket, this is the second bucket, this is the third bucket, and so on. The fourth technique on the list is web archives. Applications might evolve with time, but old bucket references sometimes remain discoverable even inside archived JavaScript files, deprecated API documentation files, or historical snapshots. Legacy infrastructure visibility often becomes valuable during attack surface discovery. As you can see, I have done an archive check in one of the Seagate web portals. The obtained JS file from historic archive can be used as an example here. If you simply fetch the JS file and search the bucket reference, here if you can see, we have found a bucket. We can try to find bucket and similar references across historically found JS files as well as config files here. The fifth technique on the list is Google Dorking. Search indexing occasionally exposes cloud infrastructure. Public search techniques combined with historical visibility sometimes identify forgotten storage resources that remain externally visible. As you can see, I have already made a search using a Google Doc. You can try to use the doc, or you can try to use other docs as well that are mentioned in my blog. In this case, we have obtained a lot of buckets that have hp.com references, as you can see. Although we have obtained many buckets here, not every bucket might be related to HP. To confirm the legitimacy, we have to verify the contents of the buckets and files obtained from them manually. The sixth technique on the list is mobile application analysis. Mobile applications frequently communicate directly with the cloud services. Decompiled APKs and hybrid mobile applications may expose storage endpoints, Firebase configurations, upload locations, CDN references, or cloud resource identifiers. Although we don't have a practical demonstration for this at the moment, we can take a look at the picture as an example. For mobile applications, we don't have any video demonstration. However, we have covered the flow of cloud innovation in mobile applications in my blog. As we can see from the image, in order to get cloud bucket references, we need to decompile the application and perform a static analysis. The application can be an APK file or an IPA file. The most the extracted files in most of the cases have CDN media references, Firebase bucket references, and if lucky, we can also have AWS, Azure, or GCP bucket references. The seventh technique on the list is subdomain enumeration. Subdomain enumeration can sometimes help identify cloud storage infrastructure used by applications for hosting static assets, media files, and other resources. In some cases, subdomains may point to a cloud storage service, and if permissions are misconfigured, files and object listing functionality may become accessible. Identifying such exposure during VAPT and red team assessments help improve cloud visibility and uncover unintended attack surface exposure. Subdomain enumeration is a good way to identify buckets sometimes. In this case, we cannot show the subdomain for an example. I am sharing a screenshot which showcases bucket listing being present in one of the resolved subdomain. The bucket name can also be seen and obtained from the listing as shown in the displayed image from my blog. I have blurred both the subdomain and bucket name here for legal purposes. However, identifying such instances is quite common in VAPT as well as red team. Last but not the least, public search platforms like Grey Hat Warfare. Public bucket search platforms can sometimes help identify publicly exposed cloud storage assets across providers like AWS, Azure, and GCP. During authorized security assessments, these visibility sources may provide additional intelligence that strengthens cloud attack surface discovery and infrastructure mapping. We have Open Grey Hat Warfare website that is a popular and well-known source to obtain cloud bucket related information on any target. We simply need to put our target name or domain in the search bar and hit the search button. The website gives us a lot of buckets that it has indexed from publicly accessible sources and resources. In this case, we are just going to hit the search button for tata.com. As you can see, we get a lot of buckets in the output. The output can then be verified and checked for its relevancy and legitimacy here. Cloud security assessments go beyond simply scanning infrastructure. Cloud enumeration and attack surface discovery play an important role in modern VAPT and red team engagements. If you found this video useful, let me know in the comments what cybersecurity topics you would like to see next. I've also linked my blog covering this topic in greater detail in the description below. Subscribe for more practical offensive security, VAPT, red teaming, and cybersecurity awareness content.